Okay, so welcome everybody to the last session of the 5-year teacher training program. Glad to see everybody here. I hope a few more people will join as we move on. I started the recording, so as always, you can put your name down for attendance, although it's perhaps not as important that we have a full record for today. But if for whatever reason you didn't get your data and you need a reimbursement later, then by all means put your name down so we have your attendance record. Okay, so thank you everybody for coming. So basically, I hope you've all had a good week. I hope you had an Eid Mubarak for those of you who celebrate. And I want to finish today with kind of spending the first half doing a little bit more of this LaTeX typesetting that we talked about last time. And I also want to show you how to make slides in LaTeX so that you can do a presentation like the ones that I do. And then we'll spend the last 30 minutes or so closing, looking back at the program and closing things out. So we'll start with just a continuation of what we did last time, and then we'll close things out. Okay. So and we'll talk at the end about certification and what the future holds and do some thank yous. So all of that will be at the end. So we'll probably do about 1 hour of LaTeX of math, and then the rest of the time we'll spend on closing material, and we'll give people a chance to say anything that they'd like to say. Okay. So I just want to recall what we were doing last time. We were talking about how to typeset mathematics. So this is a slide that we had last time, but the idea was that trying to type math using a standard keyboard is not very easy, especially once you get into complicated mathematic symbols. It can get frustrating. It's very hard to make it look nice, even if you can somehow find the keys that you want. And the global standard today for how to present and type mathematics is this program called LaTeX. This is absolutely the international global standard. And it can take a little bit of time to get used to. And we are going to be using it through this program called Overleaf that we talked about last time. And Overleaf has the advantage that it's very easy to just start up. You don't need to download any software, you don't need to install things, but it has the disadvantage that you need to be connected to the internet in order to use it. Okay, so at some point, as I said last time, if you want to use LaTeX on your own computer or phone, and but you want to be able to use it without an internet connection, then I mean, Overleaf has a version that you can pay for, but that's somewhat expensive. There are free versions that you can download, but how that works depends on what your hardware is. So it depends on what type of computer you're trying to download it to. So that's something that I don't want to go over in a large group setting because it won't be useful to most people. But if you're interested in having this software, reach out to me privately. Tell me what kind of hardware you have, and I can try to help you download it to get it onto, your computer or your phone or anything. It's not quite as simple as downloading an app onto the phone, though. It requires a little bit more work. Okay. So, but for today and for last time, we're going to talk about Overleaf. I just want to recall the procedure is that you get started with it by going to the website, which is overleaf.com. And if you go to this website, you're going to be prompted to create an account that you can do with your email address. So I'm sharing, by the way, two things at the same time. I'm sharing my slides, but I'm also sharing my Overleaf screen, which is over here. I don't know if people can see my Overleaf screen, but if you go to overleaf.com over here, you can toggle back and forth. You can enter your email and create a password, and this is going to let you sign up for a free Overleaf account. And once you have a free account, you can log in with that with your email and your password whenever you want. And as we said, a good place to get started with Overleaf is this website that I mentioned last time, this docs.overleaf.com/getting started/latex tutorials. So this is now, if you go back to my slides, this is what's being shared on the screen now. And there's a document there called Learn LaTeX in 30 Minutes. If you're interested in this and you have much more than 30 minutes, then I would recommend doing this. But I think you want to set aside 2 or 3 hours. I think 30 minutes is unrealistic. It's going to take more time to do this. So you need about 2 or 3 hours uh, to get this basic introduction, although you'll already know something from what we've done so far in the program. So I don't want to work through this because this is kind of this learn LaTeX in 30 minutes is very text heavy, and it's not as good for visual presentation. So what we did last week instead is we started this part one of the second tutorial, which was called Dr. John Lees Miller's three-part LaTeX tutorial series. This had the advantage that it's formatted using slides, so it's a more attractive visual presentation. So we did most of part one. I want to spend a little bit of time recalling what we did for review and then finishing up the rest of part one. And then I want to say a little bit about using slides. But before I do any of that, I'm going to switch my share again to the screen just so you can see again um, where all of this is found. So if I go to my screen and I go to docs.overleaf.com, getting started LaTeX tutorials, it's already there. I press enter. And now here we have these just a bunch of resources on this page. This is the Learn LaTeX in 30 minutes that I don't want to do, but is a good thing to do yourself if you have time. And this here is the three-part LaTeX tutorial series. So we worked mostly with part one, the basics. I'm going to skip part two just for time. It's something that you can also do on your own. And then part three is how to do presentations and other stuff. And we're not going to do all of part three. We're just going to do a very small part of part three today so I can show you how to make a slide for a slide presentation like what I have over here. And then there's also video tutorials if you want to watch a video. I've never watched any of these. They might be good, they might not be good, but there's a series of short videos. There's introductions that use videos. So if you want to watch, if you search YouTube and it says LaTeX tutorial for beginners, you can find videos on YouTube. So there's all sorts of resources here. I don't want to go through all of them, but all of these will be good enough to get you an introduction. I mean, I'm just trying to get you familiar, but of course, you're not going to learn everything from these 2 sessions, and you may forget things. And so I want to make sure that you're able to get these resources on your own. So all of this stuff is here under docs.overleaf.com, getting started LaTeX tutorials. Okay, so let me go back and share my slides. So if what we recall, oh, no, I don't want to do that yet. Okay, so let's go back to the first tutorial. So this is an introduction to LaTeX. I want to get part one. Okay, so this is an interactive introduction to LaTeX. Let me share this again. Let me make it a little bigger. Okay, so for anybody who was here last week, or for those of you who were not here last week, this is a short slide presentation that tells you how to do an interactive introduction to LaTeX with part one, the basics. And in fact, if you, okay, so this is just general stuff, why LaTeX is good. We don't need to go back over this. And I want to go back. We did all of this last time. I want to just remember how we get started. There was a thing to click that you could click to open this example document in Overleaf. And we did this last time. And if you want to remember what we did last time, when you open an Overleaf document, it looks like this. You're going to have two sides. You have a left-hand side, which is where you type what you want to type into the document. And then you have a right-hand side, which produces a PDF, which the PDF tells you what everything is going to actually look like. And in the end, if you want to download the PDF, where do you do that? You do File, Download. You can do Download as PDF over here. So if you want to download your PDF file, you go to File and you go to Download as PDF. Okay. So let me just very briefly go back over all of the stuff we did last time. I'm not going to be able to do a full comprehensive introduction, but hopefully some of this will be will be familiar from last time. So, a few things that we had, we recalled that if you start with uh, percentages in a line, if you put a percent sign, then the percent sign means that everything that you write after that is a comment. So it just doesn't show up at all on the PDF side. Okay, if you start things, so this is just saying, welcome to Overleaf. Just edit on the left, we'll compile it on the right. If you open the share menu, you can invite other users at the same time. Don't need to worry about that now. But because all of these things have a percent sign at the beginning, there's nothing that's written here shows up on the PDF. So, recalling how you need to start this, you always have to start the whatever you're writing with a document class and use a backslash before you type document class. And the standard document class is called article. That's how you just write standard paper. Okay. We're going to see a different document class today called Beamer, and that's how you do slide presentations. We had this extra line, use package AMS math. That was just to be able to use some extra math symbols. That was good. And then I just wanted to show you, then we had our begin document. Once you've done your document class in your article, you have to have a line that says backslash begin document. And everything is in curly braces, this begin document. So then there's a whole bunch of stuff in the document. We'll go back over that later, but then the document ends with end document, right? So you have backslash end document at the end and backslash begin document at the beginning. This is what you need to type in order to have a working document. Okay. And so the basic thing that you can do in LaTeX is you can start just by typing. So if you're just typing normal words and normal numbers and some standard punctuation, you just type it over here and it's going to show up over here. So see, I wrote, welcome to all our participants today. I'm glad to see you all attending. Today we will learn the basics of LaTeX. And it shows up right here on the PDF, exactly the same. Welcome to all of our participants today. I'm glad to see you all attending. Today we will learn the basics of LaTeX. And if I want to add a little more, I could say today we will learn the basics of LaTeX and how to make a slide presentation. So if I write how to make a slide presentation over here, I click on recompile, and what we see, oh, what just happened? What just happened here? Let's try this. Let me just, sorry. Ooh, wait, I have to log in. That's what happened. Okay, sorry about this. Gonna get back in there. Okay. No, that's not what I want. That's not what I want. I want basics. That's right. This is what I call it. Okay, so sorry. Let me just get these settings correct again. Okay. All right. Apologies for that. Okay, let's do that again. So, welcome to all of our participants today. I'm glad to see you all attending. Today we will learn the basics of LaTeX and how to make a slide presentation. So, let me just show how that all works again because that got messed up. So, basics of LaTeX, if I just recompile it, click on recompile, it just says today we will learn the basics of LaTeX. But if I add and how to, sorry, and how to make a slide presentation. And now I click recompile, you get the extra stuff over here. Okay, so we open this document in Overleaf. I wanted to mention here that even if you add lots of extra spaces, those extra spaces don't get reflected in the document. So I have a whole bunch of extra spaces here, but the document still looks nice. Notice it says, first we will open a document in Overleaf. Spacing in your typing will not be reflected in the compiled PDF, right? The spaces don't matter. Then we went through a couple of specific things with certain punctuation marks. So we saw that in order to do a quotation mark, you want to have two backticks open your quotation mark instead of the actual quotation mark sign. So hello said the cat, that leads to this hello said the cat over here. Then we saw that if you want a percentage sign, you can't just write percentage because percentage is a command to LaTeX telling it to ignore the rest of your line, make everything a comment. So if you actually want a percentage sign, you need to do backslash percentage. So if we want to say 5% of 100 is 5, we need to say 5 backslash percentage of 100 is 5. That's over here. Similar for dollar sign, you can't just use a dollar sign when you're writing because a dollar sign is your indication to LaTeX that you're doing math. So instead of just writing a dollar sign, it's the same thing. You've got to put a backslash before it to get it to actually write the dollar sign. So another way of writing $5 is 5. Okay. Then we show that you can get certain things like the rain in Spain falls mainly on the plain. That's this over here. In order to get that mainly, we had to use this backslash emph that stands for emphasis. That puts things in italics. If I wanted it in bold instead, there's a command instead of emph. I can write text BF. That stands for text BF is boldface. And now if I recompile it, the mainly is not going to be in italics anymore. You see it's been changed into bold. Okay. So you can do text boldface instead of emph to get bold instead of italics. Okay. Here was just a sentence that we wrote. Maybe I'll skip that. Maybe let's go to the math, right? So one thing that I want you to notice here is when we skip a line, when you press enter twice, that starts a new paragraph. So notice that we have this line over here, and then we start a new paragraph. So the new paragraph says, solve the following equation for x, 3x plus 7 equals 10. You notice anything that's math, we put inside dollar signs. So dollar sign before the x, dollar sign after the x. So 3x plus 7 equals 10, and that makes it look like math. It's going to look better in the dollar sign. If you take away the dollar sign, it will still work, but it's not going to look as good. So if I recompile this without the dollar sign, you see it just kind of looks like the rest of the text, where you want to distinguish what math looks like from what text looks like. So it looks much better if you put all of your math inside dollar signs. Okay? You put all of your math inside dollar signs, we recompile, and now this looks nicer. Okay? If you want the equation on its own line, then you can use two dollar signs for both the beginning and the end. So this solving the following equation for x, you put two dollar signs before the 3x plus 7 equals 10 and two dollar signs afterward, and that now gives you the 3x plus 7 equals 10 on its own line. Okay? So then we went over how to do exponents, superscripts. Um, so this over here, how to do exponents was use a caret. So a squared plus b squared equals c squared. That gave us this Pythagorean theorem right here. A squared plus b squared plus c squared. Remember, it's on its own line because we put it in double dollar signs. Then on the other hand, if we instead label the sides, here was how to get subscripts. So use an underscore instead of a caret, and that gives you S sub 1, S sub 2, and S sub 3. And you can combine them. S sub 1 squared plus S sub 2 squared equals S sub 3 squared. Putting that all in double dollar signs, that gave us exactly this equation over here. S sub 1 squared plus S sub 2 squared equaled S sub 3 squared. Okay, so moving along, we saw that if you wanted exponents that had more than one character in them, you had to put it inside curly braces to enclose it. So 2 to the 10th equals 1024. And if you want one more than one character in a subscript, like a sub 10, you've got to put that in curly braces over here. If you take out the curly braces, it gives you something that looks weird, right? If you take out the curly braces, that gives you this a sub 10 now with a big zero. The zero is not part of the subscript anymore. So you want to get it to look correct, you've got to put everything in the curly braces. Okay. Okay, and now this is back to the regular thing. We saw that we can get Greek letters. You want any Greek letter, you just type backslash and that letter. You have to be in math mode to do that. You got to be between dollar signs. So we had an equation, backslash alpha equals e to the q over rt. Again, we have a complicated superscript, so we have to put that in curly braces. And we want to get a Greek letter alpha, and you put the whole thing in dollar signs because it's math. And there you go, alpha equals e to the qrt. Um, Then you could have a big equation. If you want a capital Greek letter, you just write the Greek letter name, but you capitalize it. Use a capital omega. That gives you a capital omega. If instead I wrote it with lowercase omega and I recompile it, see what happens is that capital omega becomes a lowercase omega. But we want a capital omega. So if I do it with a capital letter, I recompile it. So this was an example. You can write summation notation. That command is \sum. Sum goes from I equals 1 up to n. You could do this with a product also. For that, you do \prod instead of \sum. And you see if you compile it with a product, it gives you a product sign here. So for sum, it gives you a sum. And for product, it gives you a product. All of this stuff is in the tutorial. I don't expect you to memorize it all. I'm just more trying to show you what this can do. And then you spend a little bit of time with the tutorial and doing your own examples. That will help you. That will help you learn it all. There were a few other things that we could do. So, for instance, to get a square root, you use \sqrt and put what you want to take a square root of in curly braces. So this is square root of b squared minus 4ac. That gives you this nice looking square root of b squared minus 4ac. And here, how do we get this fraction? You do \frac, and then you put the numerator in the first set of curly braces and the denominator in the second set of curly braces. So if I change the denominator, if instead of 2a, I wrote something wrong, I wrote 4a, I just changed the denominator there, and that's going to change the denominator here from 2a to 4a. Let me go back. I'll actually call it 2a, because that's correct. And then I should notice also that this equation has a number. We've numbered our equations. That's because I used a equation environment. Instead of just using double dollar signs, I started with begin equation and end equation. And when you do that, what comes inside, it's just like double dollar signs, but it now gets a number. That's what this begin and end equation is. Okay, so again, all of this is stuff we did last time. I just want to go over it a little bit. So what are other things that LaTeX can do for you? So it can give you lists with bullet points over here. So if I want to type some important areas of mathematics are algebra, geometry, and calculus, and I want them each to be marked with a little symbol here, I use what's called an itemize environment. Notice the entire document is in what we call a document environment, right? It starts with begin document, and down at the end, it ends with end document. So the whole thing is in this document environment. But within the document, we have other little environments like begin enumerate and end enumerate. And when you do that, you put a begin enumerate environment and an end enumerate environment. And then each thing that you want to type, you can do an item, \algebra, \item algebra, \item geometry, \item calculus. I could add another one. I could say, let's say I want probability and statistics. Okay, so I added this item. When I recompile, it's going to give me, oh, why didn't that work? Oh, sorry, I did that. I did the wrong one. Sorry, I did this in the enumerate. Sorry, I went too far down. Sorry about that. Here is where I wanted to do. We had our itemize. So the next one is item probability and statistics. Okay, now I'm going to recompile, and that gives me an extra bullet point over here, probability and statistics. Or if I want to actually list things with numbers instead of with bullet points, then instead of using an itemize environment, I can use enumerate as an environment. It's the same thing as itemize. You just write enumerate, and that's going to give me everything numbered 1, 2, 3. And if I want to add probability and statistics, I just type it in with an extra line with an item sign, and this should add this as a fourth important part of math. See, I recompile, and there you go, number 4, probability and statistics. Okay, give me 1 second. There's just somebody at my door. I have to take something. Hi. Hi, sorry about that. Okay. So where were we? Right. So you can get lists and you can put whatever other things you want to put in here. I can make a fifth important part of mathematics, maybe logic, and I recompile it, and it gives me a fifth. Oh, sorry, that's in the itemize. So I meant to put it down here. Logic. That gives me a fifth thing. That's right here. So that gives me a fifth thing in my list. Okay, and then the last things we talked about were certain functions like trigonometric functions and log and sine and min. If you put them in math mode and backslash them, they look better than if you don't backslash them. So for instance, here we're saying the minimum value of 3, 4, 5, 7, and 9 equals 3. And then there's other math functions that LaTeX knows. So if we want to say that sine of pi equals 0, we use this sine backslash pi equals 0. Log base 2 of 8 equals 3. We have log underscore 2 of 8 equals 3. And then we want to do tangent of 30 degrees. The way that we get degrees is this backslash circ that stands for circle. So we have backslash tan of 30. You have to do a superscript because if you just write 30 and then circ, then the degree thing doesn't look like 30 degrees. You just get a circle right next to the 30. So it doesn't look like a degree symbol. If you want it as a degree symbol, it's really a superscript. So you have to use your caret and put it into brackets. And that gives you this. And then you want 1 divided by square root of 3. That's that same backslash SQRT thing with 3. And then you close it with a dollar sign. Okay, and these are all, of course, in an itemized list. So they get their bullet points like that. And then the last thing that we talked about was that the symbol for infinity is this backslash infty. It's not the whole word infinity, it's just infty. Um, don't know why that's why they chose it, but that's the symbol for infinity. Okay, so this is everything that we did last time. Some of you weren't here, so of course, if you weren't here, that was way too fast to actually learn something. I just want to show you that this program is very powerful. It can make things look very nice, and at some point, you can spend a little bit more time with the tutorial if you want to learn how to do it correctly. I do want to do one more basic thing for LaTeX in this tutorial, which is to show you how to write a group of equations that are all aligned. So this is what's called an align environment. So I think so this is this tutorial. The align environment I wanted to do here. Yes. So here, imagine you want to do a sequence of equations. One thing equals another thing, which is equal to another thing, which is equal to another thing. So this here is the formula for expanding out x plus 1 cubed as an algebraic equation. So that's x plus 1 times x plus 1 times x plus 1. And you can say, okay, that's x plus 1 times the product of these two, which is x squared plus 2x plus 1. And then if you combine it all together, you get x cubed plus 3x squared plus 3x plus 1. So how do we do that? Well, we use an environment called align star. The star in general means that it doesn't number the equations. Okay, I'll show you the difference between align and align star. So let's try to type what it's doing here. Okay, so we're starting with an align environment. So I'm going to type for our new thing here, let's say begin, and then always curly braces. Overleaf will also just suggest various environments. So you see this align star, you could just click on it, but I'm just going to type it out. So begin align star. And if you do that, then I'm just going to write the end align star right here. And so what do you put in an align environment? Well, what you have is each equation gets its own line, and then you notice there's this ampersand here on each equation. The ampersand represents the alignment. So whatever's next to the ampersand, that's going to show up in the same place on every line. So here we have the ampersand is always next to the equals sign. What that means is that all of the equals signs are going to be lined up. That's usually what you want to do when you have a sequence of equations. And then the other thing to notice is that every time you want to go to the next line, you do this, you do two forward slashes, or sorry, two backslashes, two backslashes. That's how you skip from one line to the next line. So I'm going to start by just typing this out exactly, and then we'll experiment a little bit with different things to that you could put in. So let's first just type this out exactly. So we'll have x plus 1 cubed. Now I'm going to put ampersand equals. That aligns this. Well, this is equal to x plus 1 times x plus 1 times x plus 1. And then double backslash finishes the line. Now I can write ampersand equals, well, that's the same as x plus 1 times x squared plus 2x plus 1. New line, same thing, double backslash. And then lastly, this is equal to x cubed plus 3x squared plus 3x plus 1. You can see this is automatically previewing to you what it's going to look like when you type it all out. So let me recompile, and we get this system of equations exactly the way it's supposed to look. Now, what happens if I do something silly? So actually, one thing that's cool to notice is notice that in my text, these equal signs aren't aligned at all. I have ampersand equals over here, but in my next line, it's all the way over here. And in my next line after that, it's all the way over here. Right? So just because they're not aligned in my text, LaTeX knows how to align them exactly right. Okay, so it knows what to do. So you don't have to worry about how things look in what you type, because LaTeX will automatically make it look nice. Maybe I'll add a period here. Okay, so let's say I wanted to just add an extra line. I would need to do another double dollar sign. I could say this is the same thing as x cubed plus 3x squared plus 3x plus, well, 1 is the same thing as square root of 1. So maybe I could type, it's kind of silly, but I could write that as square root of 1 instead of 1. So let's see what happens here. I recompile, and it adds me a new equation where this 1 becomes a square root of 1. And notice if I put the ampersand in the wrong place, if I put it like here or something, then what it's going to do is it's going to align the 3x squared with all of these equal signs. So if I recompile this now, it's going to look weird, right? Because here now, my ampersand was here. So all of these equal signs are aligned, and then the 3x squared, which is what comes after this ampersand, is aligned with all the equal signs. So I don't want that. I don't want the 3x squared to be aligned with the equal signs. That doesn't look good, right? What looks good is to have all the equal signs aligned. So I'm going to put it back the way it was. Ampersand before the equals. That gives me everything looking normal. And then maybe the last thing I'll do is, what does this star mean? Well, if I get rid of the stars, then I can recompile, and what happens? Well, it looks exactly the same, but if you'll notice, every equation got a number over here. So they got numbered 2, 3, 4, and 5. So if you want it to number every step, because you might want to refer to it later, then without the star, it gives you automatic numbering for the equations. Usually, you don't want to number the equations unless you're really going to refer to them later. So I'm going to put the stars back in. I'm going to put the stars back in so that I don't have the numbers. So I recompile it now. It's going to be exactly the same, but the numbers disappeared over here. Okay, so that's a line. That's how this works. Okay, good. So this is like the one more basic thing that I wanted to show you. But of course, if you do the tutorials, you'll learn a lot more. But this is just a smattering of what LaTeX can do. It's very, very powerful. It can do many more things than this. But in terms of the amount of time we have, maybe this is all that I want to do. I do want to do one more exercise with everybody. So let's see. I'm going to go back to my an example. So let's see how we would write LaTeX for the following things over here. So this was in the slides last week, but we didn't get time for it. So let's say we wanted to write, here are some important trigonometric identities to know. Sine squared theta plus cosine squared theta equals 1. Cosine squared theta equals 1 plus cosine 2 theta over 2. And an angle of x degrees equals pi x over 180 radians. Okay, so I'm going to try to write, and notice that these are in a numbered list, right? The numbers, the identities are numbered, identity 1, identity 2, and identity 3. So if I wanted to type this up in LaTeX, what would I do? Well, we start with just a sentence, right? This is just normal letters and writing. So you want to write normal letters and writing in LaTeX, you just write it down. So here are some important trigonometric identities to know. I'm just going to start. Let me share my screen here. I'm going to go do that. So here are some important trigonometric identities to know. I'll just type that. So here are some important trigonometric identities to know. Okay, so that's fine. Now let me go back to my thing. Okay, so what we have here is a list where everything is numbered. So if you remember what that is, that's an enumerate environment. If we just had a list with bullet points with no numbers, that would be called itemize. But since we're listing all these things, we need an enumerate environment. So on my screen, I'm going to do this. I'm going to say begin enumerate. And then, so overleaf actually automatically gives me the end enumerate over here. But if it doesn't give you the end enumerate, then you can type that. I'm going to leave extra spaces. It doesn't matter. It can make your code look nicer. So begin enumerate. And for each identity in our list, we need to have an item, \item, just like how it's done over here. Okay, so let's see, \item. So the first one is sine squared of theta plus cosine squared of theta equals 1. So how do we write that? We're going to write, well, sine, you do \sine because it's a math function. Squared is √2. And then theta is a Greek letter, so you also get it with just \, and write the name of the letter, sine squared theta, plus, now the same thing for cosine squared theta, \cos squared theta equals 1. So that's going to be the first item. Let's just see how that works by itself. I'm just going to compile it here. Ooh, what's the problem? Oh, I didn't put it in math mode. See, it gave me an error. I got this. It didn't give me what I wanted. It still looks okay, but I got this red stuff and these red numbers, which mean errors. It's because I forgot to put it inside math mode. This is math, so I need to put $signs around it. So LaTeX will tell you when you've made a mistake. Let's try it again now, and now everything is fine. Okay, so sine squared theta plus cosine squared theta equals 1. What's our next identity? To go back and look at the page. So the next identity is cosine squared theta equals 1 plus cosine 2 theta over 2. Okay, so let's see what that is. Cosine squared theta equals 1 plus cosine 2 theta over 2. So we'll do it in math mode this time. Okay, so cosine squared theta, we already know how to do that. We already wrote that. Cosine squared theta equals, now 1 plus cosine 2 theta over 2, this is a fraction. So I have to use \frac. And then \frac, I have two sets of curly braces. The first one is for the numerator, second one is for the denominator. So the numerator was 1 plus cosine, \cos 2 theta, \theta. And then the denominator is just 2. So I just type that there. Okay. Third item was an angle of x degrees equals pi x over 180 radians. Okay. So let's go back and do this. So, sorry, I'll make this a little bit bigger for you. You can slide this over and it'll make the typing a little bit bigger. It's not that helpful, but Should be okay. So an angle, so I got to say an angle of, oh, I forgot to close my dollar sign there. I have the beginning and end of math and the end of math. So now an angle of x degrees, remember degrees was circ. So x caret circ is equal to, now we have pi x over 180 radians. Pi x over 180, that's a fraction. So I have to use fraction again. And the whole thing is math. So I'm going to put it in dollar signs again. So frac, I'm going to have a numerator and a denominator. The numerator is pi backslash pi because it's a Greek letter, x, and then divided by 180, close the dollar signs because I'm done with math now. Now I'm about to type normal text. So radians, pi over 180 radians. Okay, so that should be it. Let's go look at it so that we have the PDF more. So what happens when I recompile this? I recompile it and I get exactly what I want. I get a numbered list with exactly the identities that we want. This is the degrees. You get the pi x over 180 radians over here. And if I did something silly like I forgot to close my dollar signs and I just did it at the end of the sentence, that's going to make it treat the word radians as if it's math. It's actually going to treat it as if R, A, D, I, A, and S are all variables that are getting multiplied together, and it's going to look horrible. So if you recompile it, right, it looks like this, right? This is bad. These are italics. There's no space. It's treating these things like you have pi x over 180 times all of these variables. So that's not what you want. So you need to make sure that you end your dollar signs when you're finished typing math. So, so beginning dollar sign, end dollar sign for anything in math mode, and everything else is just outside the dollar sign. So I'll recompile this so it looks better. And there you go. Angle of x degrees is equal to pi x over 180 radians. Okay. All right. So I think that that's the only extra basic LaTeX thing that I wanted to show. Okay. Um, any questions? I know it's kind of too fast to do it on your own. You have to go through these tutorials at your own pace, but I just want to show you how you can get all of these things set up so that they work. Okay, any questions on this? Okay, so let me do briefly show you how to do a slide. So to do a slide, so this is the part 3 of the interactive introduction to LaTeX. And we're not going, so presentations and more, this tells you how to do slides and spreadsheets and pictures and things like that. I'm only going to spend 15 minutes on slides and then we'll start doing the wrap up. So really everything, this is 34 pages long, but everything that we want is on pages 8 through 10. So I'm going to scroll down to page 8. Aha. So here we are. So presentations with Beamer. So when I do slides, the name of the document class or the package that we use is called Beamer. So what is Beamer? It's a package for creating presentations in LaTeX, and it provides the Beamer document class. So remember how when we started here all the way up at the beginning, we said document class article? That's what gives you a standard article. If you want to do slides, instead of document class article, you're going to use document class Beamer. Okay? So we're going to use document class Beamer, and you still need a begin document and you still need an end document, but then there's going to be some other stuff that we're going to put in. Okay? So even before I go through this, we can click on this. It'll open an example document in Overleaf. Oh wait, no, I don't want to do it on the, I want to still have the document page. Sorry. Let me do a right click. Sorry, I want to go back. No, 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 no. Yes, here we are. Okay, so back here, my Beamer document class, here it was, this open example document. Let me open it in a new tab. I'm going to go this. I'm just going to close a couple of tabs because it's making my computer slow. Um, these are making my computer slow, so let me close these tabs. Okay. So how does this example document work? So let's see how this looks a little different from a regular document. So this text over here is exactly the same text that's in this document that you open up. Okay. So let's look a little bit about what we have. So the first important thing for a slide is you need to use Beamer as your document class. Yes, you have to use Beamer. Now, before you begin your document, you can have what's called a preamble, which means you can add your title and you can add who the author is, and you can add who the institute is, and you can add the date of presentation. So maybe the title will keep as Welcome to Beamer, but I'll change the author to my name, and I'll change the institute to where I'm from, and I'll change the date to today. So let's see what that looks like. We have our document class Beamer. Title is going to be Welcome to Beamer. Author, I'm going to change to Andrew Obis. Institute, to keep it inside the curly braces, but institute is going to be Baruch College. And the date of the presentation is May 28th, 2026. So if I recompile this now this says, Welcome to Beamer from Andrew Obis, Baruch College, May 28th, 2026. There's a little shortcut. I think if you do \today, it automatically gives you today's date. So this is a cool little feature. If you do \today and recompile, it's going to give you the same thing. It'll automatically give you today's date if you just say the date is today. But instead, I'm going to write it out, May 28th, 2026. And then here, what do we have? We have begin document and an end document. And the new different thing is that we now have a frame. A frame is a slide. So what this is saying, so you can do your first frame, and the first frame has this command \title page. And when you do \title page, that's exactly what gives you your title and your name and your institution and whatever the date is. All of that information that you put before the begin document, that goes into the title page. Okay. So now let's say I want to make a new frame. So I do another begin frame and then also an end frame. And I'm going to say, I'm just going to write, this is the second frame of my document. If I do that, now what happens? I recompile. So I still have the first page, that's the title page, but now my frame is now the second page of my slide. And it's not a very exciting frame. It just says this is the second frame of my document, but this is how I add another page to my document. It says begin frame, this is the second frame of my document. And any normal LaTeX stuff that you want to do, you can do within a frame also. So I could say, my favorite equation to solve is, and I'll put it in double dollar signs, 3x plus 7 equals 10. Okay. If I recompile it now, it does that. It says my favorite equation to solve is 3x plus 7 equals 10. Right? So any normal LaTeX stuff that you would do in normal LaTeX, you can do in a Beamer document class also. All that the Beamer document class does is it lets you do frames, and each frame is its own page. And it's supposed to look like a presentation. Okay? So for instance, so this is the page of the tutorial. Presentations with Beamer, following along. This is just to open the example document. So this says, how do you do a frame? So notice this frame has begin frame, and at the end it has end frame. It's exactly what we typed. So now here's an extra command that you can use. So this command is \frame title. And then in curly braces, what this allows you to do is give a name to each frame that you do. So \frame title, we could call it presentations with Beamer frames. That's exactly how they got their title here. So let me try to give my second frame here a title. So how will I do that? I'm going to do, so for this frame, I can do \frame title. And what do I want to call this frame? I'm going to call it my favorite equation. Okay. Now, if I recompile it, it's going to all look the same, except now my frame has a title. It's called My Favorite Equation. It's in blue in bigger letters up at the beginning of the document. So this says, Welcome to Beamer. This frame says My Favorite Equation, and I can add another frame if I want. Begin frame, end frame. I'll give it a frame title, some trigonometry will be this frame title. And now I'll say, here are the trig identities from before. And what I'm going to do is I'm going to go to my other place where we wrote these trig identities. Where do we write them? We wrote them here, and I'm just going to copy and paste them into my Beamer document. So I'm just going to highlight these, Control C. I'm going to copy the text for these trig identities. I'll put them here into my other document, paste. And so begin enumerate, item, end enumerate. And now when I recompile them, I should get those identities as a third frame here called some trigonometry. So let's see how that works. Good. So we have our title frame. We have my favorite equation frame, and now a third frame that says some trigonometry. Here are the trig identities from before. Identity 1, sine squared theta plus cosine squared theta equals 1. Identity 2, cosine squared theta equals 1 plus cosine 2 theta over 2. And identity 3, an angle of x degrees is equal to pi x radians. Question? All right. Okay, so there is more stuff about Beamer in this presentation. You can add sections, you can add a table of contents. I think I don't want to do it. You can make your presentation look like it has multiple comments. I don't want to go through all of that. It'll maybe be confusing, but I guess I should just say that you can also use color if you want. So if you want to make some of your text red or green or blue, you can use text color and then the color you want, and then the text that you want. So let's just try that because that'll look nice. Let's say I want to make my here are the trig identities from before. Let's say I want to make before green. So I'll do backslash text color, and then I'll have green, and then before the green is in braces and the before is in braces. And if I recompile it, that should turn the before green. There you are, right? So now my before is in green. And if I want the trig to be in blue, I do the same thing. Backslash text color, and blue, and trig. And that's going to turn the word trig into blue. Right, now the trig is blue. Okay, so you can play with this however you want. But yeah, so these are just some extra options that you have with Beamer. You can change color of anything that you want to change. And I think that's maybe it. Yeah, so text boldface is the same thing. Emph is the same thing as what we had. There's a couple of other things called alert and text italics. I'm not going to do them, and then there's a link here in the tutorial. I've actually never followed this link, but I guess it has colors and custom colors. Never mind, that doesn't work. Okay, forget it. We won't use that link. So where were we? Page 12. Yeah, so you can also put pictures in if you have a picture. I'm not going to talk about that now because it'll take a little bit too much time, but you can put in pictures. You can put in tables that look like this. You can do blocks. You can make larger print and smaller print. You can have different themes. There's different ways of generally making your presentation look, different backgrounds, all sorts of stuff. And maybe I won't talk about any of the rest. Let me just say very, very quickly, you can draw pictures in LaTeX. There's something called TixZ, which lets you draw pictures. You can draw graphs and put you can draw graphs and you can put numbers for coordinates. You can draw all sorts of arrows inside your graph. You can draw paths inside your graph. You can fill things in with colors. You can make the arrows colors. You can make shapes colors, kind of an endless amount of stuff that you can do. You can put shapes inside your graphs. You can label arrows with Greek letters or with regular letters. So, I mean, you can draw graphs of functions in different colors. So, there's just all sorts of different things that you can do with LaTeX. Okay, and if you really know some more difficult things, you can draw complicated geometric figures. You can draw concept charts here. You can draw. This is something about electronics, but you can figure out lots of graphics that you can do in in um, in Tixi, which is part of LaTeX. Okay, so maybe I'm not going to say anything more about this. Okay, so only scratching the surface here. I just wanted to show you the very basics of how to do a Beamer slide presentation, which is what I do. So this is how I've made all the slides for all of our workshops, is by using this document class Beamer and putting each slide in a frame. As a matter of fact, if you want to see what my slides look like, let me share my. Oh no, I closed them already. Okay, never mind. Never mind. Okay. Um, so you can use this Beamer to go make these slides. Okay. And if you want to learn more about it, you can look at the entire tutorial. Okay, any questions here? Okay, so let me go back to my slides then. Okay, so again, this introduction to LaTeX, but I think you'll see that things that you write can really look a lot better, and there's always more to learn. I am by no means an expert on LaTeX. I am a competent user. I can use it for what I need, but there are people who really know a lot more about it than I do. But the good news is you don't need to know that much about it in order to just get started using. Following one of these tutorials is really enough knowledge to start writing things down. And I should say, and this is, of course, all going to change in the next several years, but all of the AI chatbots now can write LaTeX for you. So if you go into ChatGPT and say, give me LaTeX code for the following three trig identities. I mean, let's even do this right now. I want to just experiment with this. I haven't done before. So if I go to ChatGPT, let me share my screen here. Um, if I go to ChatGPT, let's try this. I go to ChatGPT. So I just want to close a couple of documents. Some of these are making my computer run slowly. Okay. So if I go to ChatGPT and I say something like, write me LaTeX code for an itemized list giving the following trig identities. And then I'll say, the first one is sine squared theta plus cosine squared theta equals 1. So I'll say number 1 is this, sine squared theta plus cosine squared theta is 1. Oh, wait. Oh, and see, it just gives you the code already, right? I mean, it's right there. So, and then the second one will be maybe cosine squared theta equals, and I'll just write it in like standard thing. So 1 plus cosine 2 theta divided by 2. I'm not being careful at all with my LaTeX syntax or anything. And now, see, it just gives you the code right away. Begin itemize. It gives you your item. It gives you your begin itemize. It does the item and it does the frac and it puts everything in dollar signs. It does it exactly the way you want. Okay, so to some extent, as these chatbots get better and better and get cheaper and more accessible, they can do a lot of the work for you in LaTeX. They can just give you exactly the code that you need to write it down. But I think it's also worth knowing a little bit about how the system works. Okay. But I do think over the next 5 years or so, it's going to become maybe a little less important to know this because AI is just going to do this stuff for you if you need it. Okay, so AI can write LaTeX code for you, and you can just kind of tell it, what you want the document to look like, and it will help you do it. Okay, any questions here? Okay, all right. So if there's no questions, let me go back to the screen to my slides. So this is just the slide saying you can use this document class Beamer to make a slide. It's how I make slides for the workshop. And if you want to understand how it works, then then you can look at this part three of this three-part LaTeX tutorial series. And when we only covered this very, very small part, there's a lot more that you can do. Okay. So I think that's all I want to say about LaTeX. I hope that for some of you, it will end up being useful for you, either in your teaching or just anytime you're writing something. I mean, right now, even when I'm not typing math, if I write a letter of recommendation, if I write the syllabus for this class, everything that I write in LaTeX. I find that it makes it look more professional. It looks, it adds, I think, an automatic degree of professionalism to just about anything that you do. So I think hopefully, especially that you're all mathematically inclined, that, at least at some point in your career, being able to type things in LaTeX will be beneficial to you. Okay, and it's certainly good for making slide presentations that involve math, right? I mean, PowerPoint and Keynote can do basic things, but this Beamer is kind of very specially uh, made in order to do mathematical presentations. So if you ever end up leading a workshop, you may be able to use Beamer slides for it, and they'll look good. Okay, so that's I think it for the content for this year. Just want to look back a little bit over here. So we say in the past 5 years of the program, what did we do? I guess not a few people have been with us since the beginning, but not everybody. So so we started with the first year we did exponents and trigonometry and logarithms and probability, just a bunch of advanced topics. The next year we only did one semester, but we focused on vectors and matrices. The year after that, we did statistics and geometry and trigonometry. The year after that, that was last year when we had a calculus workshop. And this year, we covered lots and lots of different topics, but the focus was always, what are tools for you to carry this work on, for you to make your own workshop, regardless of what the topic is. So we did geometry and we did logarithms and we did solving equations with word problems and we did calculus and we practiced for we did circle formulas and we did practice for the WITS math competition and we finished up with all of this LaTeX. But the thread that was hopefully running through all of this semester was what is going on behind the scenes? How do I plan a workshop lesson and what do I need to do to make it work? So most of that was about the mathematics and the presentation. And at the very end, I wanted to say a little bit about what is the technology that is, of course, not necessary. If you get a group of people together in a room, you can write on a board and that works fine. But for doing anything remote, it's good to have, visual slides to show. And ultimately, I think the best way to do slides like this, if you're trying to do math, is to use Beamer and LaTeX. Okay. There's a little bit of learning at the beginning, but once you've done that learning, then the dividends are really large and it gets easier to write. Okay, so this is what we've done. What is the future? So as I've mentioned, this is the final year of the teacher training program. There's not going to be a regularly meeting weekly class next year. The the grant funding for the NSF that funds this program is a 5 year thing, and it's not renewable. And in terms of for me, I'm not going to have time to be planning a regular weekly class next year. So what does this mean for the future? So first of all, you've made a network through this program. I think many of you, if you didn't know each other already, now you do. So I certainly encourage you to continue working with each other, spreading the knowledge that you've gained in the last 5 years to your fellow teachers. I think we've had about maybe 80 participants total over the 5 years of this workshop, maybe closer to 100 if you count everybody who's shown up once, but probably only about 50 in total who really showed up regularly and came to lots of meetings. But so a lot of you have maybe met each other. So one thing that I certainly encourage you to do, I mean, I know a lot of you are from all over, although mostly Nimba and Montserrato. If you want to form a coalition of local math teachers who meet on a regular basis every week, probably too ambitious. But even if it's only once a month or once every other month to meet, share knowledge about classroom techniques, or to have a presentation on a math topic that, is maybe confusing to somebody and somebody else wants to present about it, that would be a great idea. This would also be a great thing if you know other teachers in your school or in neighboring schools who are not part of this program, but might want access to some of what you learned in this program to convene a group to do that is an excellent idea. And if you do organize something like this, if you do have a group meeting on a regular basis next year, whether that's a big group meeting on Zoom or a smaller local group meeting together in person, then I'm certainly happy to give an occasional guest presentation to these groups. If you meet in a room that has a good display for Zoom, as long as I can present visually remotely, then I'm happy to drop in and give a presentation every once in a while. What else about the future continued in terms of resources? I want you to remember that all of the videos are on my YouTube channel. This is my YouTube channel over here. It has all of the videos since the beginning of the class. Uh, Maybe it doesn't have the first year. I don't remember. It may have only started in the second year. I have to check. All of the lecture notes have been shared with the WhatsApp chat as well as the Art of Problem Solving book. Now, that's not so great because these lecture notes are just scattered along some really, really huge WhatsApp chat. So one of the things that I want to do is to collect all of the relevant files, all the lecture notes, all the textbooks, all of the handouts, everything like that. I'm going to put them I can't put them on my website because I'm actually not given enough space on my website to do that. But what I'm going to do is put them all in a Dropbox folder. So I don't know if any of you have used Dropbox, but it's a way to share documents from computer to computer. And what I'll do is I'll give everybody the invitation to join this Dropbox folder. And in this folder, when you join it, you'll be able to open it up and you'll be able to see all of the lecture notes sorted by date for all of the workshops that have happened over the 5 years. So I haven't done that yet, but I'm going to do that this summer so that everything can be accessed and found easily. And yeah, I just want to emphasize that even though we're not having a regular meeting, I'm not going to be disappearing. We're going to have the WhatsApp chat. I'm going to read in that. I'm going to write in that. I'm not going to be out of touch. You have my email if you need it. It's andrewobis@gmail.com, and you have my WhatsApp. So I will, certainly still play a part in this group. And I hope that the chat doesn't just die. I hope that you all continue to play a part in it, that you use the chat to show interesting things to each other and to help organize any kinds of meetings that you may want to have. So what I want to close and say, this community of teachers is very special. You show up every week, some of you for many, many years on end. And so I want you to take advantage of the fact that you really are a network now and that you've been through a lot in this program. Okay, so that's what I want to say about the future. More immediate future certification. So the certificates are going to be given to everybody who participated substantially in the program this year. This is the usual thing. So if you attended a significant number of classes, you'll receive a certificate of participation. If you attended almost all of the classes, then you'll receive a certificate of completion. And certificate of distinction will be given to a few people who not only attended almost all of the classes, but also significantly enhanced the class through their active participation and or effort on the homework problems. So this is not quite right. So the 2025-2026 certificates have already arrived in Liberia, although Abraham Jabated doesn't have them yet. He should be getting them this summer. But they're already printed out and they're already in Liberia. So somebody was able to carry them there. And there will at some point be a combined certification ceremony for the last 3 years of the program. So that's the 2023-24, 2024-25, and 2025-26. So I think they're all going to be signed by the same minister. This is Nathaniel Sisko, who's in charge of STEM and special and vocational education, I believe, at the MOE. So all of the certificates are signed by me, and then they'll also be signed by him. I don't know details about when we're aiming to do this certification ceremony. Do Abraham or Deborah have any further information on when we're trying to do this, or if we're having separate ceremony in Ganta and in Monrovia?
Hi, everyone. Concerning the certification program,
Mhm.
it will be into two parts, the Maserati and Ganta. So all of the certificates will be put together. That is it for this last class today. Certificates will be combined with the previous certificates that we have. And then we are still anticipating on doing the program next July, hopefully. Yeah. So when it gets signed by the minister, and then we will sort it out, separate contact from Maserati, and then we come up with the actual date in July to to have the programs, but we're having to contact in Maserati.
And Abraham, do you want to say again what you said at the
Yeah,
beginning? Because more people are here now.
yeah. By the grace of God, I'm going to be receiving it on Saturday. Then Monday morning, I'm going to carry to the ministry. Then the minister would ask the minister to sign all the certificate that the new certificate that to be signed. Then we're going to distribute it, search it out. Which one? When I sort of come to Ganta, we take it out. When I sort of with me as muscle rider, we want to have that one. Then we're going to put in the chat room now when actually we're going to have the program that everybody going to be there. Everybody going to be there. But one for this particular program to be extra from the others one that we've been doing before. But one
Okay.
for everybody to be take part inside the program. And first of all, I would like to tell all the teachers that took part into the training that thank you for taking part in the training. And we are planning again to see what we will do next. If we come back, then we will also invite you into that program too. So thank you, Andrew. Thank you very much for this class.
All right. Thank you. And just to reiterate, I think people have been sending their address, their contact information to Abraham in the chat room. This is going to help with the certification ceremony. So if you have not yet sent that information in the chat, please go ahead and send it to the chat so that they know how many people are in each county for doing the certification. Um, all right. Okay. So that's what I want to say about the certification for now. Okay, so I want to give some acknowledgments at the end. So, of course, as Abraham said, I want to echo Abraham's thanks to all of the teachers for showing up every week, for paying attention. Now, life is never easy. There's always lots and lots of things to do. There's family, work, there's everything else you need to do. So I greatly appreciate that you show up every week and are able to come and participate in the program, and for some of you over many, many years. So thank you. I want to give really extra special thanks to Deborah Strother, who has been, at least with the teacher training program, basically single-handedly organizing it throughout the entire year, and also doing a lot for the WITS math competition, keeping track of all of the attendance, keeping track of all the data, encouraging everybody to come in, and just for Deborah, she's not somebody who's been doing this for all 5 years. She stepped in the middle of the program when her assistance was
Yeah,
necessary, and she's
hello,
done wonderfully. Yes, Enoch.
hello, Dad.
Yes,
Yeah, it's me,
Enoch. Yeah, hi.
Yeah, I want to inquire something about the certificate and stuff because we have learned some people have spent 2, 3 years, some people spend 1 year, some people spend a few times there. So the certificate will it be given or issued based on the time you have spent, like A certificate, B
Yes.
certificate, C certificate, or BSc?
Yeah, each year has its own certificates. So if you participated all three, this certificate has the specific year on it. So if you participated all 3 years, you'll get three separate certificates, one for each year. So each year I made its own certificates.
Okay,
So
because
yeah,
yeah, I've been thinking it would be something that because certificate issue have been categorized. Like for example, if you spend like 13 months or 14 months, something like that, or like for example, they fight 2 semesters, it go for C certificate, like 3 semesters, it go for B certificate, 4 semesters, it go for A
right.
certificate. Just like that, what I'm thinking.
Exactly, yeah. So it's one, there's just separate certificates. So if you participated in 2023-24 and 2025-26, you'll get a separate certificate for each of those years that marks the year of participation. So each certificate marks the specific year you participated, and you get as many as the number of years that you did.
Okay, understood.
Okay, great. Thanks. Okay, so let me go back. I can't thank Deborah enough. I put together these slides, but this program doesn't work without the team in Liberia. So, and especially Deborah is really doing everything this year. So, and stepped in about 2 years ago to start doing that. So, I want to thank her especially for that. Without her, this program just doesn't happen. Um, and then, of course, I also want to thank Sanjay Freeman. I want to thank Sanjay Freeman. Rosh, do you have a comment? If not, can you stay muted, please?
Yeah, same message, but anyway,
Oh,
no
sorry.
problem.
Okay.
Okay, thank you very much, Dada Usa, for the knowledge that giving us. May the Almighty bless you and give you long life and the entire team. Thanks to our mother, which is Mother Deborah, for her work. It's not easy. It's not easy, seriously. Yeah, she really do well. Thank you very much. Hello.
Okay, yes, thank you. Thank you.
Hello.
Thank you.
Yes, hello?
Yes.
Hello?
Hello, Dad.
Yes, Prince.
Yeah, yeah, Prince. Thank you so much for the recognition. I I really, really want to take this time to appreciate you for the past years because, like, for me, I've been in the program for the past 4 years, the year make it full, and I've been seeing lot from you, even from the academic area, from helping area, all these places. So I just want to take this time to appreciate you. You are doing extremely well for us, and this will never go unnoticed, for us in Liberia. So we say thank you, and on behalf of the teachers all over, I will say thank you for the time, and we pray that we should now go away so we should continue being taught as to go on and on because there are some places we need of you more to come in. So thank you once again. I really, really want to appreciate you a lot.
All right. Thank you, Prince, and thank you for participating so consistently over all these years with so much energy.
Uh,
Sorry. Hello. So I also want to, can I just say a little more? I want to thank also, of course, Sanjay, who started everything out as the main person who's running everything. Sorry, Rosh, can you just stay muted until I'm done because there's an echo? Thanks. So for Sanjay, who did everything at the beginning of the program and really got this program off the ground, and Abraham as well, who not only has been assisting with this program, but in all of my trips to Liberia back in 2011, in 2013, and 2017 was, my guide on the ground and, moved mountains to make all of those workshops happen. So I can't thank you enough, Abraham. And it's really special to still have you here for the program. And I want to thank Charles Brotle and Alexander Nakamu Jr. also for all of your help with the WITS math competition, keeping all of the receipts, all of the records, sending me all of the pictures, making sure everything runs smoothly. It's not an easy task. And of course, I can't do it from here. So thank you both for all of your help with the program. And I want to, as institutions, also various support. So the Liberian Ministry of Education, the National Science Foundation, which has provided all of the data funding for this workshop. My university, Baruch College, for always being supportive of me in letting me take the time to do this. And even though it's not really part of my job, but my university's always been extremely supportive of this. And then the I Help Liberia project, which got me involved in everything. And with this I Help Liberia project, of course, we have to thank all of our godfather here, Asumana Jabate Randolph, who hasn't been here for most of the sessions this week, but this year, but is here today. And without him, I would have never known, I would have barely been able to find Liberia on a map. So, I mean, he is the reason I've been involved with everything for the last 15 years. And he's been the person who's always encouraged me to, do the best that I can to advance science and math education in Liberia. So I think we all owe him a very serious debt of gratitude. And certainly for me, it's been such a meaningful aspect of my life, and I think it's improved so many people's lives in Liberia. And so I just want to thank Asamana, or Coach, as I call him, for everything that he's done. You're here. I don't know if you can talk right now, but I don't know if you want to just say something quickly. I don't know if you're driving or if you're able to talk. Um, Okay, so Asamana may not be able to talk right now. He may be in the middle of driving or doing something else, but hopefully he can hear that all of his effort and inspiration is greatly appreciated. Um, Okay, so I mean that's basically it. I'll say thank you all again for your participation and attention this year, but we have, 5 more minutes. So if anybody has any more questions or any comments, anything they'd like to say, we'll open the floor to any participant who would like to speak.
Dr. Obus, Jasper, how you doing?
Jasper, I'm doing good. How are you?
Yes, sir.
Yep.
I'm okay. Thank you so much for the time with us. I remember the first time I interacted with you, it was 2013 when you came with some students in Kakata from Harvard for this mathematical science workshop. I was one of the teachers that was part of the training.
Oh, wow.
And again, I'm in your class for another training. I want to say thank you for looking back to the Liberian teachers for your effort. We appreciate it a whole lot. And we always hope to see you around again for more impartation. Thank you, Doc.
All right, you're welcome. That's so great.
Hi,
Were you teaching at
everyone.
BWI then?
I was at KRTTI.
Oh, KRTTI. Yeah. Okay.
Yes. Yes.
Okay. Great.
Hi, everyone.
Hi, Miyata.
Yeah.
Oh, wait, sorry. I didn't mean to mute you. Sorry, the thing changed. You can unmute.
I want to take this time to thank the organizing body of this mathematical class, and most especially to the I Help family, I Help Liberia family, and our outstanding teacher or professor that over us. We want to be very grateful. And we also thank the Ministry of Education for the level of
cooperation they have had alongside with the training team. So we will really miss this class, and the impact is cannot be fully described, but along our professional journeys, we are really going to appreciate all that you have done. Thank you so much.
All right, thank you. And my apologies. I remember Miata was also involved in organizing the WITS math competition, at least perhaps this year and certainly last year. So I want to apologize for that oversight, and I want to thank you for your help with that organization also.
Yeah, no problem.
Thank you. Yes.
Yes. Okay.
Who's speaking? Rush?
Yeah.
Deborah.
I just wanted to know something, man. Getting the certificate, does the certificate have, like, for instance, where you have A certificate, B certificate for the training, or it's not having anything like that?
I don't think I don't have the authority to confer a title in the Liberian, like something that gives you the right to teach a certain class. No, I mean the certificate is signed by me, but I don't have the authority from the Liberian Ministry of Education to give a certificate like that.
Okay.
Okay.
No problem.
Okay. Deborah speaking again. I want to appreciate every one of us for participating in this program, especially Madam Sange Freeman from the Ministry of Education. She has been one of the driving force behind my working with I Help Liberia, and appreciate Mr. And then I want to say thank you to Ibrahim Jabatia too as well. Through it all, they're guiding me through the process too as well. And I want to appreciate us for the time putting in every time to for teachers out here. I know it has been challenging, sometimes network issues, data conflict, and all of that. But at least to come to the end of this program today is something that is so good. I must commend all of you guys that really participate. Although some of you we used to force in all for database, but yet we stay friends, and some of you without the stay text, oh, how you doing, mother? How you doing, bro? Like checking up. Appreciate all of you guys. And have learned this, we should not just sit on it, to try to apply in our classrooms, and even we can host tutorials, organize that, like example, so it's giving the entry, and so you can even volunteer to do tutorial classes for the honor graduates as well. So I want to appreciate all of us and encourage us. We should go out there and apply it. So thank you very much.
All right, you're most welcome. Okay, would anybody else like to speak before I close the chat room? Okay, well, if that's it, then I just want to thank all of you for coming with me on this journey for the last 5 years, and it's not over yet, and I'm excited to see where it's going to go. So thank you again for everything. As always, I'll post the notes, I'll post the video, and this has been such a special thing for me, and hopefully for all of you. So thank you again. Thank you for all of the helpers, and I will be seeing you on the chat room.